Hello CHEM203 students, I'm Mrs. Teresa Marrawi, Chemistry Lab Instructor. Today we will be performing the fourth experiment of the course entitled Spectrophotometry. In the first part of the experiment, we will be measuring the absorbance of a 0.05 molar chromium nitrate solution at different wavelengths between 350 and 600 at a 25 nanometer interval. The solution is prepared in distilled water, so our blank will be distilled water. This is a cuvette that will be used in the spectrophotometer equipment. You can see the transparent part of the cuvette. This is a UV visible spectrophotometer used to measure the absorbance in the visible range used today. So we will start by filling our cuvette with distilled water, the blank. The light passes in the spectrophotometer in this way. So the transparent part must be settled like this in order for the light to pass. And now we have to set our lambda by pressing lambda button 350. Then we will press like a cuvette filled with a solution, which is the blank bottom. And now we have a zero value for the blank. Now we have to pass our solution the 0.05 molar chromium nitrate. We have to make sure that there is no fingerprint in the transparent part of the cuvette, because our fingerprints affect our results. And now we have the first value of absorbance for a 350 nanometer. It is 0.121. Let's move to the second wavelength, 375. Because we are changing the wavelengths at each time we have to pass our blank. Again, we change our lambda 375 and we press the blank button. We settle our solution and we record the value of absorbance for a 375 nanometer wavelength. It is 415. Let's move to the third wavelength at lambda 575. Passing our blank. Then we will insert our chromium nitrate solution. A value of 0.661 absorbance is obtained. And finally, the last wavelength, 600 nanometer. So as I said, since we are changing the wavelength at each time, we have to pass our blank. We put our solution and we record the value of absorbance. Here are our results. So if we can compare our results, we can find that an absorbance of 0.744 is the highest at a lambda max of 400 nanometer. By plotting the curve of the absorbance versus our lambda using all the results obtained, we can find that the maximum absorbance is 0.744 at a lambda of 400 nanometer, which reflect our lambda max, the maximum wavelength. After selecting our lambda max, which is 400 nanometer, now we can measure the absorbance of different concentrations of chromium nitrate solution, 0.04 molar, 0.03, 0.02, 0.01, in addition to an unknown concentration of chromium nitrate. All these solutions will be measured at a lambda of 400 nanometer, the maximum wavelength. So the blank is still the same, water. So we select our lambda max, which is 400 nanometer. We pass our blank. Already the 0.05 molar is done for an absorbance of 0.744. Now we will move to the 0.04 molar solution. We will fill our cuvette. We always make sure that the light should pass through the transparent part of the cuvette. And we record the value of absorbance, which is 0.594 for a 0.04 molar solution. Please note that in this part, we should pass the blank just once. Why? Because we are using just one wavelength, which is 400 nanometer. We are not changing our wavelength. Let's move to the 0.03 molar solution chromium nitrate in order to detect its absorbance. So at this time, you should not press anything. You just put the cuvette inside the spectrophotometer and the value will appear on the screen. It is a 0.459 absorbance. Moving to the 0.02 molar solution, same procedure, a value of 0.302 absorbance is obtained. Again, 0.01 molar solution chromium nitrate will get an absorbance of 0.149. Finally, we will measure the absorbance of an unknown prepared chromium nitrate solution. We don't know its concentration. You have to find it while you draw the graph of A versus C, having an absorbance of 0.368, you can directly draw the graph from the obtained value, and you can identify the concentration of the unknown from your graph. In the last part of the experiment, we will be preparing 4 different solutions with different concentrations, A, B, C, D, starting with a solution of 4 times 10 to the power minus 3 molar CHEM203 already prepared with H2SO4 as a diluent. In this part, we will perform dilution and mixing, and then we will be measuring the absorbance of the different solutions obtained. So, solution A will be prepared from the mother solution already prepared in a 250 milliliter volumetric flask, which will have a concentration as per the manual of 4 times 10 to the power minus 4 molar. So through dilution calculations, we can deduce that we have to pipette 25 milliliter of the mother solution into the volumetric flask, and then using H2SO4 as a diluent till the mark. So we never pipette directly from a volumetric flask, so we have to use a beaker. This is a graduated 25 milliliter pipette. Pipetting 25 milliliter of the mother solution into the 250 milliliter volumetric flask marked as solution A. So as I said at the beginning that the mother solution is already prepared in an H2SO4 solution, we have to complete the volume using the same diluent, which is H2SO4 0.5 molar. We can use a funnel. So as soon as we approach the mark, we stop adding directly from the beaker, and it's better to use a dropper. So we add H2SO4 using a dropper until we reach the mark. Solution A is ready. We homogenize. Done. Then we will prepare solution B. Solution B will be prepared in a 200 milliliter volumetric flask using solution A. We will be pipetting from solution A 100 milliliter into the 200 milliliter volumetric flask. 100 milliliter of solution A are pipetted inside the 200 milliliter volumetric flask marked as solution B. Now we will complete the volume using the same diluent H2SO4. We use a dropper in order to adjust the mark of the volumetric flask. Solution B is ready. We homogenize. Now we will prepare solution C. Solution C will be prepared from solution B by pipetting 50 ml solution B in a 100 milliliter volumetric flask labeled as solution C. So 50 ml of solution B are pipetted inside the volumetric flask of solution C. We complete the volume with acid H2SO4. Then we use a dropper to adjust the meniscus. Solution C ready and homogenized. finally, we have to prepare our solution D, which will be prepared from solution A and B by mixing 25 milliliter of A and 25 milliliter of B. So we will pipette 25 milliliter of A in a 50 ml milliliter volumetric flask labeled as solution D. And after adding the 25 milliliter of solution A, we will complete the volume with solution B. Our solution D is ready and homogenized. So now we have solution A, B, C, and D ready in order to measure their absorbance. 525. The absorbance of the following prepared solutions will be measured at a given wavelength 525 nanometer. As the solutions are prepared in an H2SO4 solution as a diluent, so directly we have to know that the blank that will be used is an H2SO4 solution. So as they have given us the wavelengths 525 nanometer in order to measure the absorbance of the prepared solution, this wavelength is the best wavelength reflecting the maximum wavelengths given. Since they have did the job on behalf of us, they have did what we have done with the chromium nitrate solution while we have chosen the best wavelengths. Okay, so let's start now by filling our blank inside the cuvette. The blank is H2SO4. It is ready. So I will fill all the cuvettes in order to be ready directly to measure their absorbance in the spectrophotometer. In addition to the 4 prepared solutions, you will be given also an unknown prepared solution of CHEM203. You have to deduce later on the concentration from the graph. We will also measure its absorbance at 525 nanometer. Now we will move to the spectrophotometer. We will select our wavelength, which is 525 nanometer. We pass our blank. Since we are given a wavelength of 525 nanometer as the best wavelength, the maximum wavelength, we should only pass the blank once. So after zeroing the machine, we can pass all our solution without passing our blank again. This is solution A. Solution A, absorbance 0.895. Moving to solution B. (0.455) absorbance. Solution C, 0.223 absorbance. The absorbance of solution D, 0.696, and finally our unknown concentration given solution will be 0.760 as absorbance. And we are done with our experiment.